Assalamualaikum and good evening. My name is Muhammad Iqbal bin Ahmad Iman from Group 1. Today I will talk about the introduction of AET, Acoustic Emission Testing. AET, phenomenon of sound and ultrasound wave radiation in materials undergo deformation and fracture processes. AE signals. This provide information on the origin and importance of discontinuities in a material. AET is a new technique for leak testing. It is also assumed as a large-scale strain gauge. When a piece of equipment is subjected to an external stimulus, such as a change in pressure, load, or temperature, this triggers the release of energy in the form of stress wave, which propagate to the surface and are recorded by sensors. Where it uses almost the same principle as leak testing, where it introduces sound wave to detect defect without the need to enter the vessels as shown in the figure, where it can analyze the strain stress inner structure of AET instrument. Acoustic emission instrumentation. Typical AET apparatus consists of the following components. The major component is the four of it is a sensor, preamplifier, cables, and data acquisition device. Sensor is used to detect AE events, and preamplifiers which amplifies initial signal. Cables is used to transfer signal on distance up to 200 meters to AE device. Cables are typically of coaxial type. Data acquisition device is used to perform filtration, signal, parameters evaluation, data analysis, and charting. For the next, I will pass it to my next group member. Thanks.
Okay, thank you. So now I'll be presenting about the acoustic emission principle, where generally for AET it has four stages of step, where the first one is detection of acoustic emission, where source of AE include many different mechanisms of deformation and fracture, whilst the detection process remains the same. As cracks grow, a number of emissions are released. When AE wave front arrive at the surface of test specimen, minute movement of the surface molecules occur, where AE sensors is to detect the mechanical movement and convert it into a usable electrical signal. For the second step is the processing of acoustic emission signal, where small voltage generated by the sensor is amplified and raw radio frequency RF signal is transferred to the data acquisition device. Based on the user-defined characteristic, the RF signal is split into discrete waveform. These waveforms are then being prescribed by the characteristics such as the amplitudes, the rise time, absolute energy based on user-defined threshold. And for the third is displaying AE signals, where the collected waveform can then be displayed in two ways. The first one is the function of waveform parameters, and the second one is collected waveform. Most AET only record the waveform parameters and ignore the collected waveform, mainly due to the large amount of computing memory it uses. And lastly of those four is locating AE signals, where the automated source location capability of AE is perhaps its most significant attraction as an NDT technique, where a predominant method of source locating is based on the measurement of the time difference between arrival of individual AE signals at different sensors in an array. So in comparison to other NDT method, AET helps you to indicate the exact location of the defect on the test specimen, whereas for other method you have to perform testing from an area to another area in order to detect the defect. Okay, next I'll be talking about the acoustic emission test technique. So for acoustic emission testing technique, for AET, it is defined as a transient elastic wave generated by rapid release of energy within a material. So when a structure is subjected to an external stimulus, like change in pressure, load, or temperature, localized source trigger the release of energy, which is in the form of stress wave, which propagate to the surface and are recorded by sensors. This occurs when a small surface displacement of a material is produced, as shown in the figure. Or to be simply put, when a material talk when they are in trouble, acoustic emission equipment will listen to the sounds of crack growing or fiber breaking and many other modes of active damage in the stress material. This data will be shown in the AET instrument. Okay, I'll give an example. Initially, we have an inclusion in the sample. So, when a load is applied to the sample, it disturbs the defect, which causes acoustic emission in the sample. This acoustic emission is then being captured by a sensor which absorbs the signal and then is sent to an amplifier as an AE has a very low energy like I have mentioned before, and lastly it is being sent to the data acquisition device to be analyzed for the location of the emission or the location of the defect. So now I'll be present about the acoustic emission source location technique. So technically they have 4 types, where for the first one is multiple channel source location technique, where it allows to record a hit from a single AE event. Hits are recorded by each sensor, where the source can be located by knowing the velocity of wave in the material and the difference in hit arrival times among the sensor, which measure by hardware or computer software. This enables to locate the location of the defect in a workpiece or a specimen. So for the second one is the linear location technique, where it is often used to evaluate struts on thrust bridges. Source is located at midpoint, like shown in this figure, where the time arrival difference for the wave at 2 sensors is 0. Whether the location lies to the right or left of the midpoint, it is determined by which sensor for record the hit, which help to locate the defect between the 2 sensors. For the location techniques for AE is point location, where the signals are detected in a minimum number of sensors. So for this method, they have 3 different types, where 2 for linear, 3 for planar, and 4 for volumetric. Besides, accurate arrival times must also be available, where the velocity of wave propagation and exact position of the sensor are the necessary criteria. Once all the data are being collected, the equation can then be derived using sensors array geometry or more complex algebra to locate more specific points of the interest. And lastly is the zonal location technique, where it is aimed to trace the wave to a specific zone or region around a sensor, or where zones can be in length, areas, or volumes depending on the dimension of the array. Plus, when additional sensors are applied, arrival times and amplitudes help to pinpoint the source zone. So that's all from me. Next, I'll pass to the next presenter.
Thank you. Okay, I will present about standard and specifications. Okay, this is standards for AET as shown in this slide. It is standard for AET also. Next is application for AET. Okay. First, weld monitoring. During welding process, temperature change induce stress between the weld and base metal. These stress are often relieved by heat treating the weld. Second is bucket truck integrity evaluation. Accidents, overload, and fatigue can all occur when operating bucket trucks or other aerial equipment. If a mechanical or structural defect is ignored, this can result serious injury or even fatality. That is breach. Breach contains many weld joints and combination of load and environmental factors. This will influence damage mechanisms such as fatigue cracking and metal thinning due to corrosion. Acoustic emission is used for monitoring because it can continuously gather data and detect change to the bridge. And the fourth is aerospace structure. Aerospace structures consist of complex assemblies of components that are designed to carry significant load. It has been used in laboratory structural tests as well as in flight test applications. So this is other applications, which is petrochemical and chemical for storage tanks, reactor vessels, offshore platform, and drill pipe. Next is electric utilities for nuclear reactor vessels, piping, steam generators, and ceramic insulators. Next is fiber reinforced polymer matrix composites for glass fiber reinforced parts or structures. And we have material research for investigation of material properties, breakdown mechanism, and damage behavior. And lastly, real-time leakage test and location for within various components like small valves, steam lines, and tank bottoms. Okay, that's all from us. Thank you.